Again, welcome back my channel, The Learning Destinations. I'm your host Avinash, and this is session number 02 of my ongoing series Teleport, and where I'm going to show you the high level architecture overview of the teleport. So in these sessions, we are going to see that exactly what happens when the users tries to establish the connectivity with the Kubernetes clusters, with the web applications or the database. So in such cases, how teleport plays its role, how the connectivity made between the client and the server. So these all things we are going to understand from this tutorial. So those users who haven't yet watched my session number 01, where I had given the in-depth explanations about the teleport, I request you to please go into the playlist of the teleport and watch the session number 01 and jump into this sections. So all these things we are going to understand from this session number 02. Before I move to the next sessions, I would request my all visitors, please subscribe my channel and press the bell icon as well. So now I'm going to show you the high level architecture overview. Let's enjoy this journey. Okay guys, so let's first understand what is teleport. Although I had already explained it in my session number 01, but since currently we are going to understand the high level overview architecture of the teleport, so we must understand it. So in a short form, teleport is an identity aware multi-protocol access proxy which implements protocols such as SSH, RDP, HTTPS, Kubernetes API, MySQL, PostgreSQL and others. So these are the protocols which teleport as a proxy helping in connecting with such protocols. Now let's understand the teleport architectures, and there are mainly three services which are responsible to perform all actions inside the teleform. The first is teleform auth services. Basically the teleform auth services acts like a CA, certificate authority, and which issues certificate to the client to connect with the Kubernetes cluster, databases, web applications or RDP. Now secondly comes teleport proxy services, and it allows access to cluster resources from outside, and this is only the service available in public network. So basically this proxy service is listening under the public network, and let's suppose that I as a user try to connect some resources inside the teleport cluster, and those resources are Kubernetes clusters. So I as a user am also inside the public network, and when I request to connect those resources inside the teleport clusters, firstly the resource comes to the proxy, and then finally the proxy it sends request to the auth services. This is what we are going to understand later on this tutorial as well. Then finally comes the teleport node, and the node services basically speaks its native protocols such as SSH, Kubernetes API, HTTPS, PostgreSQL or MySQL. I need to correct it here. It's not MyDQL, it's MySQL protocol. It acts like a smart sidecar, and it routes user requests from proxy to its target request. So the last line, if you see that, it is pretty much clear that what its role, the teleport node. The role is that when the request comes to the proxy, right, and then from proxy to it moves to the particular resources inside the teleport cluster, then that request is being moved by the teleport node only. Okay guys, so now I am putting everything onto the one table, and let's understand the high level architectures of the teleport. So let's suppose that there is a users who try to establish the connectivity with the Kubernetes cluster. Now I am going to explain you that what is the process happening behind the teleport when a user try to connect the resources as a Kubernetes cluster. So when I explain this user under the public network, the user request goes to firstly to the proxy, and you can see that the proxy is itself listening on under the one address, okay, and which is listening on the port number 3080. So when you request inside the teleport, guys, this URL I'm going to explain you under the practical sessions, probably in session 03, where I will show you that when you try to connect with the resources using the teleport, firstly the request goes to proxy, and in this proxy basically this address will be open in your web browser. So from there you need to mention your user ID and password, And then if it is a two-factor authentications, you need to put OTP. That OTP you can generate through the Google Authenticator. If two-factor authentication has set, then only. And you can use Microsoft Authenticator as well. But if you are using SSO kind of login, you are login with the help of GitHub, then you need to use the OAuth 2 protocols. So let's return back on the explanation. So when the user try to connect to the resources Kubernetes cluster, the request first come to the proxy, and after going into this particular address, you need to pass your user ID password, and then you need to authentications. After that, the user identity goes to this auth service, and finally auth service issues the certificate respective to that particular resources, and it issues certificate to the users and as well as that particular resources as well. Then everything, this record now maintains by the authentication inside the audit log. So whenever you need that who has accessed your particular resources in past, you can always take the record from the audit log. Then finally, since this auth certificate, this auth services issues the certificate to this particular resources, right? So that's how that your user can get the connectivity with these resources. So if let's suppose that this user wants to get connected with the Kubernetes cluster, so it made the request, then the proxy authenticate the first users by visiting this particular link, and then it passes the identity to authentication services. This authentication services, this CA, certificate authority, issues the certificate for this particular resources and send confirmations to the user, and that's how that these users has established the connectivity with these resources, and simultaneously everything is getting recorded inside the audit log. So in the same way, you can keep the you can connect with other resources as well, like the database, web applications, Kubernetes cluster, SSH node, desktop access. So basically the desktop access, when I say, let's suppose that you have 10 workstations inside your organizations and you have 10 users, so you can give permissions accordingly to your desktop access, and you can keep the permission restricted by the policy implemented policy, and you can keep the control from the teleport as well. In the same way, if your database is under the NAT gateway, right, in the same way you can provide the connectivity to your database. Web application, let's suppose that your web application is running on the third-party network, and that's how that the proxy can give you the connectivity of your web applications, such as like IoT devices, like self-driving vehicle. If it is any medical equipment, inside there is some applications which you can connect through this particular teleport as well. Then you can connect with the Kubernetes cluster, and you can connect with the different nodes as well. So everything is getting issued through this particular CA, which issues the certificate, maintains the log inside the audit, and through the proxy it gets confirmations, and then finally it gets the connectivity. This approach also saves us from the honeypot attackers. Since I had already explained that how cluster works by using the animations, but still in the theoretical way you can understand it. Users and server both joins the same cluster before access can be granted, and that access can be granted by the CA, certificate authority. That's what I had explained in my previous slide. In order to join cluster, both user and server must authenticate and receive certificate. This is what I told you, like when the users try to connect with the server, right? Firstly, the request goes to the proxy. Proxy verifies the identity of the users by visiting the link proxy.example.com on the port number 3080. Once it is verified the user identity, then proxy forward the request to the CA, the certificate authority, and where the CA issues the certificate. The teleport or service is the CA of the cluster, which issues certificate for all supported protocol, whether it's a SSH, whether it's a RDP, or whether it's a any other protocol. So that's how that exactly the teleport cluster works. Now we know that whatever the action is being performed, it is getting recorded inside the audit logs, and which CEO also maintains the audit logs. So basically audit logs consist of two sections. One is called event log, and where it captures the security event logs such as event includes login attempts, file transfer, code executions, file system changes, or network activity. And second section is that it records all the interactive sessions to the cluster nodes via the SSH and kubectl commands are recorded for future replay. So this is all about, guys, about the high level overview architecture of the teleport, and this is exactly that how teleport works. So now I believe that your concept towards the teleport architecture overview and its connectivity is pretty much clear. Your understanding about different services of the teleport is quite clear, but still if you have any doubt, you can write me in the comment sections. So that's all for the day, guys, and I hope you really enjoyed this tutorial. If you have any questions, you can write me comment sections anytime. Any suggestions, feedback are always welcome. Stay tuned with the learning destinations. Don't forget to watch my upcoming sections, session number 03, where I'm going to cover all the practical sessions. And one more request, guys, please don't forget to subscribe my channel and share it with your family and friends as well. Thank you so much for watching this. I will see you in my next session, session number 03. Till the time, bye bye. Thank you so much. You have a good day.